There we go. Label the parts of this atom. When you read your instructions, it's very, very, very important that you pay attention to the vocabulary they are using. Here they said label the parts of the atom. What kind of clues does that give us? What does that tell us? Nick? Okay, it's okay not to know. Nucleus, protons, electrons, and neutrons. So we know that it's an atom and it has these things in it. What do we know about the vocabulary word atom? It is neutral. So right at the top of your paper, if you don't know this, it's okay not to know it, but I want you to write it down. I want you to write down this is neutral. And if it is neutral, what do we know about things that are neutral? Charlie, go ahead. They have no charge, so I'm gonna make that in a different color. Ooh, look at how pretty that is. No charge. How does it have no charge? Well, go ahead.
There's a amount of positively charged and negatively charged particles.
Right, it has the same number of positives and negatives. All right, let's narrow it down even more. What's the positive?
Same amount of protons and electrons.
Good. Protons, which are positively charged, and electrons, which are negatively charged. I cannot even believe that one little word means so much. Right? Do you understand how the vocabulary really narrows us down into what we are really being asked about? Okay, so the protons, just so that we know, will be abbreviated P with a little plus sign because they are positively charged. And electrons are going to be abbreviated E with a little minus sign because they are negatively charged. So if I have 5 positives and 5 negatives, I have an overall charge of 0. Okay, so this one little word led us down this big, gigantic rabbit hole. All right, and then, like Nick said, we have to use these words. Nucleus, proton, which we said was P positive, electron, which is E minus, and a neutron, which is neutral. Okay, and we abbreviate with that with an N0. All right, they give us this little picture, and they want us to label it. I'm going to get out my highlighter here so we can all see. I'll use green. This top line right here is this whole thing. What is that whole thing referring to? Joe? The nucleus. So let's write nucleus in here. Ashley. Right? Caitlin. Okay, Caitlin. What do you think this line is referring to? This one right here. This kind of like funky looking L-shaped line. The electrons. Good. I'm going to write that here. So, if this thing is the electrons, which it really is the orbit of these electrons, or what we call the orbital because it's the modern model, these that are black, I'm going to color them in red. These are the electrons. You with me? Okay, so we're going to make those E minus. How many electrons does this atom have? 3. Okay, so it's got 3. Knowing that information, we've got 2 other lines here. We've got either this line, which I will highlight in orange, or this line, which I'll highlight in blue. Out of the orange and the blue, which one is pointing towards the protons and why? Ash, go ahead.
The blue one, because there's 3 protons.
Okay, so because we knew that the number of protons and the number of electrons had to be equal, because we're dealing with an atom, this line, which is the white right here, has to be equal to the protons. Let's grab a pen and let's write that in, protons. And that means this thing over here, these black ones, have to be equal to the neutrons. And we abbreviate neutrons N with a little 0. How did I do? Awesome. Do you understand what's happening? Okie dokie, Smokey. Let's move on. Okay. Oh, you know what? Before we move on, where's the mass of this atom located? In the nucleus. And what would the mass of this atom be? The mass number, Charlie? It would be 7. So if I have an X that represents my symbol, where would I write that 7? Will? Top left. That is the mass number. And what number would I write down here in the bottom left? Hold on a second. Shayla? 3. Because it has a number of protons, right? If I called on you, try to call on everybody at least once. Anna, you awake back there? Okay, you're up next. Ready? Okay. The subatomic particle with no electrical charge. What is that called? Say it like you mean it. You don't know? It's okay not to know, guys. Somebody who does know, tell her so that she knows next time. Say it loud. Neutron. Okay? No charge. Neutron. I'm going to abbreviate it with an N with a little 0. Okay? Which particle has a positive charge? Olivia, do you know? Protons. And the abbreviation for that is a P with a positive charge. And then which particle has a negative charge? Go ahead, Aiden. An electron. Good. How are we feeling? Better? All right. There are the same number of these two particles. Again, they use the word atom. Okay, if they use the word atom, we know that the number of protons and the number of electrons have to be the same. Okay, we took a little hiatus from this for a couple of days to get those labs done, but we're back. So, there are the same number of these two particles in the atom. Jack, what are they? Protons and electrons. See how I'm using the P's and the E's so that we don't have to write the whole word out? Get used to those. All right, the atomic number is the same as the number of... Lily? Okay, hold on. Let's dissect this question. The total atomic number. So let's get it right here. This is the atomic number in the bottom left corner. Do you remember what this number stood for? It stood for the number of protons, the atomic number, the number of electrons in a neutral atom, and the nuclear charge. Okay, does that help us? Let's go back to that question. It says the atomic number is the same as the number of protons. Good. Say it like you mean it. Even if you're wrong, trust me, nothing's going to happen to you. Okay, so the atomic number is the same as the number of protons. It's also the same as the number of electrons if it's a neutral atom, the atomic number, and the nuclear charge. And just remember the nuclear charge is always going to be positive. Where is the mass located, Alina? The nucleus. Because the protons and the neutrons are both in the nucleus. Jasper, you good over there? Because you're behind me, so it's hard to see. Okay. These two guys right here have mass. Their mass is 1 atomic mass unit. If you forgot, you can look at that chart that we drew a few days ago. All right, which particles... Oh. Look at that. Noah, what did I do? My big mouth got me in trouble, right? Which particles account for the mass of the atom? There we go. Protons and neutrons. Good. All right. Everybody have a periodic table in front of them? You're going to need it. Okay, I'm just going to the next page because I have it and I can move it up a little higher. Okay, here we go. We have something that has an atomic number of 9. If its atomic number is 9, what is its symbol, and how did you know that's its symbol, Will? Fluorine.
I knew it was F because I looked at the periodic table at number 9.
That's what I would do. The atomic number, let's go over here and grab the periodic table. And you see how fluorine in the bottom left corner has a little 9? That 9 is the atomic number. Every fluorine has 9 for this number. And that number tells us the number of protons. It tells us the number of electrons if it is neutral. So it tells us a lot of information. So if we go back over here, that fluorine, the atomic number is 9. How many protons does it have? 9. Abby, good? Okay. Now, the mass. See where it says mass right here? Okay. They're talking about a mass number. What is the mass number of this fluorine? 19. This 18.9984 is an average atomic mass. The mass is going to be whatever this is rounded to the nearest whole number, because that's going to tell us what we have the most of. In this case, we're going to have the most fluorine 19s. You would write it fluorine-19. Hey, it rhymes. That number is the mass number. I'm using the one we have the most of, and I got that from here. So if we say the mass is 19, can we now find the number of neutrons? Don't give me the answer. Tell me how you did it. Andrew, how do you do it? You don't know? Okay, he needs some help. Go.
Subtract the amount of protons from the mass.
Right. So we have these two numbers. You see how this number is bigger? The mass is bigger. You're going to take the mass, which is in the upper left-hand corner. Where the heck did my paper go? Here it is. This is the mass. This is the mass number if it's a whole number. It's the atomic mass if it's a decimal. The mass number is equal to the protons and the neutrons together. I have to say, that is a pretty good little squiggly that I just drew there. You should be impressed. Lila, you impressed? Be impressed. Okay, so if this is protons and neutrons, then this one is protons down here. If I take the bigger number and subtract the smaller number from it, I'm going to get the number of neutrons. Here's my paper. Okay, so 19 minus 9, the mass minus the protons, or the mass minus the atomic number, these numbers are the same, is going to give me 10 neutrons. All right, let's deal with the electrons now. How many electrons should it have? Why 9? Why is it 9?
Because that's the same amount of electrons, protons, keep the neutral charge.
Keep the neutral charge. So because these are protons and electrons, one's positive, one's negative, and we know we're dealing with an atom, okay, this is an atom, then the number of protons and the number of electrons are going to be the same. That is not going to always be the case, but we're not going to call them atoms if it's not the case. Atoms have equal number of protons and electrons. All right, P. What element is P? Somebody said it out there. Phosphorus. Good. Phosphorus. I'm just writing it here so we know. Okay. What is its atomic number? 15. Which means it's going to have 15 protons. Nora, you got that? You know where it came from? Okay. Let's deal with the mass. We'll go over to the periodic table. Lucky for me, it's right here, P. What is the mass number I'm going to use? Nick? 31. I like it. 31. Because I'm using the most abundant mass, which is 31. And if I have 31 as its mass and 15 as its protons, how do you find number of neutrons? Subtract. Okay, take the mass and subtract the protons from the mass. So that'll give us 16. Doing some quick math in our heads. All right, how many electrons will it have? 15, I like it. Okay, easy peasy lemon squeezy so far? Okay, let's finish this up. The atomic number is the number of blank in one atom of an element. Shayla? Protons. Write a little P with a plus sign. Okay. It is also the number of blank in a neutral atom. Nicole, do you know? You got it, girl. All right, electrons. The atomic number gives the identity of the element. No two different elements will have the same atomic number. If it has one proton, it's hydrogen. If it has two, it's helium. All right, the blank of an element is the average mass of the element's naturally occurring atoms or isotopes. The what of the element? Atomic mass. I like it. Not the mass number. The mass number isn't exact. The atomic mass is the average. Okay? Taking into account there's a couple words we can use here. We can use percentage. We can use abundance. We can use how many, taking into account how many of each isotope. Obviously, whatever you have the most of is what your average is going to be closer to. And that's why we can just round this and we can get a mass number. In order to calculate the number of neutrons, you must subtract the blank from the blank. Be careful of the order that you put these in. We are subtracting the
Atomic number from the mass.
perfect. Atomic number. I'm going to use the number sign. That's not a hashtag. You guys know that's a number sign? Okay, good. And from the mass number. All right. Last but not least, give the symbol and the number of protons in one atom, and I want you to write it in atomic notation. I'm going to do this on the next page just because I don't have room. So let's start with lithium. Okay? It wants you to write the symbol, which I just wrote for you, I shouldn't have done that, and the number of protons. Where would I write the number of protons? Nick? Bottom left. How many? 3. Okay, I don't like that 3. I'm going to rewrite it. There you go. Okay? If I asked you to write the mass up here, what mass would you put? 7. That's the most abundant isotope of lithium. All right, what was the next one? Mercury? Okay, what's the symbol for mercury? Hg. It was one of the 35 I said you should probably know. Okay, and what is its atomic number? How many protons does it have? 80. For those of you who don't know, you can take a trip to Mercury. There it is, right there, 80. And its mass number would be 201. Okay? And then finally, what was the last one? What is it? Iron? All right, iron, symbol Fe. We take a trip over to iron. It gets 26 protons. And we'll give it a mass number of 56. This is called atomic notation. Okay, so you have your mass up here, atomic number down here, all good in the hood, right? All right, let me stop the tape.